Okay, Pete, today we are going to talk about the different types of solutions and equations that you will see for the rest of the school year. We've been working with one particular type of equation, and that is the equation that has one solution. Every time we solve for x, we get an actual answer for what x is. But sometimes you're going to run across other types of equations. So here are your vocabulary for this lesson. You have one solution, which are the ones that we've been doing, where you solve for x, and you get one answer for what x is. Also, you can have an equation where you have no solution, and what that means is that you are going to solve an equation, you're going to try to solve for x, and you are going to come up with an answer that may look like 4 equals 0, or 3 equals 22, or x equals, and you can't have that, you'd have to, x equals negative x, something like this, where you know that 4 does not equal 0, and 3 does not equal 2, and x does not equal negative x. None of these equal each other. So that would be called an equation that has no solution, or sometimes we call that a null set. So if you see the words null set, just think N for null and N for no. It means you do not have any solution. And then the third type of equation that you may encounter is called an identity. And that means that you will come up with an answer that maybe looks like 4 equals 4, 2 equals 2, 22 equals 22. And basically what that means is that no matter what you substitute for x, any number at all in the whole world, both sides of the equation are always going to equal each other. So we're going to go ahead and practice a couple of these types of equations so that you can see exactly what it's going to look like. So here's the first example, and this is the type that we've been working on for the last couple of weeks. So let's go ahead and draw our train tracks, and then we can box the variables. And of course, if you don't see a sign there, we know it's positive. And here we have another variable, and there's no sign there, so we know it's positive. And then we can circle our numbers that do not contain variables. And of course, we circle the sign with it. Okay, so first I would like to work on our boxes which contain the variable. And I always like to move the smaller number that's attached to the variable. So in this case, it would be the 7, just because it's easier to work with. So I'm going to have to subtract 7d from both sides because the original 7d is a positive. So subtract 7d from both sides because what I do to one side, I do to the other. And what's going to happen here is that's going to cancel out and give me 0. But we don't need to write that. And 15 minus 7d is going to be 8d. I haven't done anything with that positive 20, so I'll bring that down. And I haven't done anything with that negative 4, so I'll bring that down also. Now I can box and circle again. For those of us who like to do the boxing and circling, I enjoy it. Helps me see things a little better. And we'll circle that and circle that. Well, now I see that I've got these two circles that need to be combined. So I'm going to move this 20 by subtracting it from both sides because it's being added here. So I have to do the opposite. So I'm going to subtract from both sides. And the reason I moved the 20 instead of the 4 is because if I move the 4 over here, then there wouldn't be anything left on this side, and we can't have a side with nothing left. So this cancels out, leaving me with 8d on this side. And a negative 4 and negative 20 equals negative 24. And then I know that when they're smushed together like this, the coefficient and the variable, it means they're being multiplied. And to undo multiplication, I do division. So I'm going to divide both sides by 8. And I'm left with D over here because that cancels out. And then I've got negative 24 divided by 8, and I know that that equals negative 3. So that is one solution. That's a one solution problem where I end up with an answer where D actually equals something. And of course, you know I can check that by putting negative 3 in for D instead of the D. So I've got 15D, which is negative 3, plus 20 equals 7. The D was negative 3, minus 4. And I can do 15 times 3 is going to be negative 45, plus 20 equals 7 times negative 3 is negative 21, minus 4. And then I've got 45 minus 20, which is going to equal negative 25. And negative 21 and negative 4 equals negative 25. So I know that my answer of D equals negative 3 is correct. Okay, then I can go to no solution or the null set like we talked about earlier. Remember the N for no and N for null. And we're going to do this the same way that we would do any other equation, and we're going to go ahead and box our numbers that do not have variables. Box that. We'll box the 7 with its negative sign. We'll box the 5 with the positive sign. And then we can circle the ones with the variables. So we've got that positive 3x there. We've got that 6x there that we know is positive because it has no sign. And we've got a negative 3x there. Okay? Well, I know first that I can combine these two boxes on this side. So if I combine a positive 11 and a negative 7, I'm going to get a positive 4. I didn't do anything with that 3x, so I'm going to keep that the same. And then I can see I've got two circles on this side here, so I can combine those like terms, and a 6x and a negative 3x is going to combine together to make 3x. And I didn't do anything with that positive 5, so I'll bring him down and keep him the same. And now I've got a new equation here that's simplified, and I can box and circle again. So I will circle the variables with the sign, and I know that this 3x over here is positive because there's nothing with it. And I can box the numbers that are not attached to a variable, and box that positive sign with that. Okay? Now I'm going to do my boxes first. So I need to move one of these. So I like to move the smaller number because it's easier. So that's a positive, so I need to do negative. So I'm going to subtract 4 from both sides, which cancels out right there, and it leaves me with 3x here. And then 5 minus 4 is 1, and that's a positive 1, and I didn't do anything with that 3x, so I will bring it down. And then I can box and circle again, so I'll do that one, that's a positive 3x, and that one, which is also a positive 3x. And then I can box our positive 1 right here. Okay? Now I need to combine these circles here. So I need to move this one over because if I move this one to this side, nothing will be on this side, and we can't have a side with nothing on it. So we're going to subtract 3x from both sides because the original is positive, and we do the opposite. So subtract 3x from both sides. So that cancels out, and on this side I'm left with that positive 1. And this also cancels out because I've got a 3 minus 3. 3 minus 3, people, is 0. So I have 0 on that side. And we know that 0 does not equal 1. Zero never equals 1. If you have $0 on your bank account, that does not mean that you have $1 in your bank account. It means you have 0. So 0 is never going to equal none or 1. So that means that this problem has no solution. No solution is ever going to work in this problem to solve for x. Okay? Here's our next example. This one is called an identity, and we're going to, again, solve it the exact same way. And it will come out showing us that it's an identity, which means that no matter what we substitute in for n, it's always going to work. So let's go ahead and box our variables. So that's a positive 2. We have a negative 5n here. We've got a negative 3n here. And then we can circle the numbers that we have in the equation that do not have a variable attached. And we know that that 2 is a positive 2. And we have that positive 9 there. Okay, so let's combine like terms on each side first. So I can go ahead and combine these. And I've got a positive 2 and a positive 9, which gives me a positive 11. And I didn't do anything with that, so that's going to stay the same. So that is a negative 3n. And I didn't do anything with this, so I'm going to bring that down. That stays a positive 11. But on this side, I can combine these two boxes. And I know that negative 5 plus 2 is going to be negative 3n. Okay, so that is what my equation looks like once I have simplified. Okay, so next I am going to box and circle again. And I will box that. And I will box that because they both have a variable attached. And I will circle this, and I will circle this because neither of them have a variable attached. So let's do the boxes first. I'm going to combine these two. And because that's negative right now, I'm going to go ahead and do the opposite and add it, make it positive. And I do that to both sides. And so over here, I get 0. And over here, I get 0 again, because negative 3 plus 3 is 0, and negative 3 plus 3 is 0, which leaves me with this positive 11, because I haven't used it yet, and this positive 11, which I haven't used that yet. And so look at this. I have 11 equals 11. Remember I told you when you have something that equals itself, so 11 equals 11, that means no matter what you put inside for these n's, it's always going to work. So this means that you have an identity. So let's try that out and see how it works. So let's say that we substitute in 1 for n. So n equals 1. If we do 2n, which we said is going to be 1, minus 5n, which we're going to put 1 in, plus 11, equals 2 minus 3n, which we said was 1, plus 9. We can substitute, okay, so 2 times 1 is 2, minus 5 times 1 is 5, plus 11 equals 2. Negative 3 times 1 is negative 3, plus 9. And then I've got 2 minus 5, which is negative 3 plus 11. And I've got 2 minus 3, which is negative 1 plus 9. And negative 3 plus 11 is going to equal 8. And negative 1 plus 9 is going to equal 8. So you check that out. Totally works. Well, let's go ahead and make it 2 just to see. So let's say n equals 2. And it should work because if it truly is an identity, it doesn't matter what number I substitute for n, it will always work. So we'll say 2n, which we said was going to be 2 this time, minus 5n, which we said was going to be 2, plus 11 equals 2 minus 3n, which we said was going to be 2, plus 9. 2 times 2 is 4, minus 5 times 2 is 10, plus 11 equals 2, negative 3 times 2 is negative 6, plus 9. 4 minus 10 is going to be negative 6 plus 11. 2 minus 6 is going to be negative 4 plus 9. Negative 6 plus 11 is 5. And negative 4 plus 9 is 5. And check that out. It works again. So there truly is going to be an identity, this problem, because no matter what we substitute for n, it's always going to end up checking out. Okay? Okay, let's try the next one. Oh, check this out. We have to decide. Is it one solution? Is it no solution or null set? Or is it an identity where no matter what we put in, it's going to equal the same? So let's go ahead and work it out and see what we get. So first we're going to put a box around anything that has a variable. So we've got that negative 5r. We have the positive 4r. We have this negative r here. And you know if there's no coefficient here, it's automatically a 1, right? Just to remind you. And then we've got this negative 6 here and a positive 2 there. All right, so first what I'm going to do is I'm going to go ahead and combine these boxes on the same side. So negative 5r plus 4r is going to give me a positive 1r. I did not do anything with that negative 6, so I'll keep it the same. And I did not do anything over here, so I will keep that the same also. I'm going to box and circle again. No, that's positive, and that is negative. And I'm going to circle that one and circle that one. And then I am going to get rid of this. So I'm going to move this over here to this one. So in order to do that, ooh, I made a mistake. Let's fix that. This is actually supposed to be a negative 1r. Silly me. Thanks for catching my mistake, guys. So that's actually going to be a negative 1r because I had a negative 5 and a positive 4 there. So because it's a negative, I'm going to go ahead and add 1r, add 1r, and let's see what I got here. Well, negative 1 plus 1, that cancels out and gives me 0. I have that negative 6 that I haven't done anything with yet, so I'll bring that down. Negative 1 plus 1, that cancels out, and that ends up being 0. And I've got that positive 2, so I bring that down. Well, I need the zeros. So I have negative 6 equals 2. Well, but negative 6 is never going to equal 2. No matter what we do, negative 6 never equals 2. So our answer for this one is going to be that this does not have a solution, so it's a null set or no solution problem. Okay, let's try the next one. We have 6x minus 9 equals 10x plus 7. So let's go ahead and box everything that's got a variable and make sure we give it a sign if it doesn't have one. If it doesn't have a sign, we automatically know it's positive. And then we will circle our numbers that do not have a variable attached. All right, so let's go ahead and combine our boxes first. So I'm going to go ahead and move the 6x over here because I like to move the smaller numbers. They're easier to work with. So because that's a positive, I'm going to do the opposite, which is negative. So subtract 6x from both sides, because what we do to one side, we do to the other. Plus 6 minus 6 cancels out and gives me 0. I did not do anything with that negative 9, so I will bring that negative 9 down. 10x minus 6x is going to give me 4x. I did not do anything with that 7, so I will bring him down too. And now I can see that I've got this 9 here and this 7 here, and I've got this 4 attached to the x here. So I need to combine the circles this time. Okay, so I want to move this away from the x, and also because if I move the 9 over here, nothing would be on this side, and we can't have that. So this is a positive, or it's being added, and to undo addition, we do the opposite, which is subtraction. So we're going to subtract 7 from both sides. And I have a positive 7 and a negative 7, which cancels out, it gives me 0. And I have a -9 and a -7, which when I combine them together gives me a -16. And then I've got this 4x that I haven't done anything with, so I bring him down. And because these two are being multiplied together, to undo multiplication, I do division. So I go ahead and divide both sides by 4, and I am left with x equals -4. So I actually have a solution that I can check. Let's go ahead and check that. So 6 times x, which is -4, minus 9 equals 10x, which is -4, plus 7. 6 times -4 is -24, minus 9 equals 10 times -4 is going to be -40, plus 7. -4 and -9 together equal -33. And -40 plus 7 together equal -33. So that I know my answer of -4 is correct. And because I actually have a solution, I know what x is, that means that this problem is this type. We have a one solution problem here. Okay? All right, let's try one more. And we're going to go ahead and solve this the same way we solve all the other problems. Draw our train tracks. Okay, now before I can box and circle, you know I have to take care of these parentheses. We always take care of the parentheses first. And anytime we see parentheses, we know we distribute, which means that we're going to multiply what's on the outside by everything on the inside. So I'm going to multiply this -3 times x, which will give me -3x. And the -3 times the -2, which will give me a +6. I did not do anything on this side, so I'm going to keep this full side the same. And then I can go ahead and box and circle. So we'll put boxes around anything that's got variables. So I've got my 3x there and 3x there, okay? And I'm going to circle this and this. I'm going to let it positive. Okay, I want to take care of my boxes first because that's what I like to do. And because that's negative, I'm going to do the opposite. So I'm going to add 3x to both sides. So -3 and 3x together, they equal 0, so they cancel out. And I've got a -3 and a +3, which equals 0, so they cancel out, which leaves me with a 6 on this side and a 6 on this side. And remember what we said, anytime that you have anything that equals itself, that means that it's an identity, which no matter what we stick in for x could equal 1, x could equal 2, x could equal 322, x could equal -322. No matter what we put in for x, it's always going to end up working itself out. So that means that we have an identity here, which means that we have many, 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 many solutions, as many numbers as you can come up with. Okay, if you have any questions about one solution, no solution or null set, or identity solution, which means you have many solutions, if you have any questions about these three, please make sure you bring them to class. This will be on your test. Okay, have a great evening.